Welcome back to the Math Professors. If you enjoy content that can be found in any college math class, please consider liking, subscribing, and sharing. I'm Professor Van Hamlin, and I'm going to cover the derivative of a function today. More specifically, what I'm going to cover is I'm going to do the derivative of the function and explain that the derivative of a function is also a function. And much of our examples today are going to be the more complicated examples you might find in like the later part of your homework. A lot of explanations are done with very simple functions. Let's do some challenging ones so then you feel comfortable with hard ones as well. So, in the previous video, I explained the derivative of a function at a particular point, and we knew that that was the limit of the slope of the secant line. So, the derivative of the function still has that same flavor, except instead of just finding the slope of the tangent line, which is the limit of the slope of the secant line, at one point, I'm going to do it for all points. And when I do it for all points, that means every input is also going to be associated with the slope of the tangent line. So every input's going to have an output, which means that we're going to get another function here. Now, I've chosen this function kind of wisely. This is a function, y is equal to x squared, and I know its derivative is going to be 2x. And we'll verify that in a second here. So what I want to show you is that if I want to find f prime of x, well, f prime of x is going to be another function. So if this blue function is f of x, if this is f of x, then this function here is going to be equal to f prime of x. So we have is this. Now, I'm not trying to show tangent at a particular point. What I'm trying to show you is that this function represents the slopes of f at every single point x. So what I mean by that is, like, if I pick an x value over here, what I can tell you is the slope of the tangent line is going to look like this. It's going to be a negative value. So I should get a negative output. Now, as I go, further negative, you can see that the slopes are going to get steeper, which means I'm going to be more negative slope. So, as I go further, the slope is going to be more negative, negative being, down here. And if I pick x value, say, over here like this for an x value, you can see the slope is going to be positive. If I pick an x value here, the slope is going to be steeper, so more positive. So, the slope here is going to be a positive number. The slope here is going to be more positive, positive going up. The outputs are going to be more and more positive as I go up. So again, negative slopes, very negative over here, less negative, less negative. Actually, at this particular point, the slope of the tangent line is going to be, 0 at that point. So that's why I got an output of 0. Looks like the slope here is about 1, so I get an output of, y equals 1. So, so really, again, the pink curve represents the slopes of the blue curve at every single point. So again, that the derivative of the function is also a function. So I was going to verify that with x squared. This will be the simple one, and then we're going to get to some more challenging ones. So an example would be, find the derivative, find f prime of x for, say, f of x is equal just x squared. So in order to do that, we know that f prime of x, or df dx, is going to be equal to the limit as h approaches 0 of f of x plus h minus f of x, and this is all going to be over h. Now, just like we did before, we would plug in, x naught plus h for some particular x naught, but I don't want it for, any x naught. What I'm really looking for is I want this for every single x value, so I'm going to leave this as just x. So this is going to be equal to the limit as h approaches 0 of, well, this x plus h is going to go into this x location, so this is going to be, the function is x squared inputted with an x plus h here, minus f of x, which is going to be this original function. This entire thing is f of x, so minus x squared, and this is all going to be over h. Now, the way we do this is we're going to expand and simplify the way we would if I had a constant in here. So this is going to be equal to the limit as h approaches 0 of, x plus h times x plus h. Then I have to do the powers first before I can simplify. So when I FOIL, x squared xh, another xh, so 2xh, and then plus h squared. So this is going to be the limit as h approaches 0, x squared plus 2xh plus h squared. And I still have this minus x squared all over h. Now, very similar to what happened with the derivative at points, I'm really kind of hoping to get rid of this h at the bottom. So the only terms I would like to still have on top is terms that have an h in them. And I can see that, this x squared doesn't have an h in it. This x squared doesn't have an h in it. That's nice. So those get to go away. And now I can factor an h out of this numerator. So limit as h goes to 0 of h, and I have 2x plus h all over h. And now those h's cancel. And now this function is defined at h is equal to 0, so I can plug in 0. So this is 2x plus 0, which means f prime of x is equal to that 2x. So this kind of verifies if I have a function that is x squared, that was f of x was equal to x squared, then I know that its derivative, which is right here, f prime of x, was equal to 2x. Which, again, you can graph it as a line. I know it doesn't look like it has a slope of 2, but let's say it looks steeper than it actually is. So, or is steeper than it actually looks. So, let's do some more complicated ones and get a feel for those. So let's go ahead and find the derivative of f of x, which is equal to this cubic. So 2x cubed minus 3x squared using, the limit of the difference quotient. So f prime of x is going to be equal to the limit as h approaches 0 of, again, it's f of x plus h minus f of x all over h. Ava, I'm trying to do something. What's up? I hear you guys stomping around up there. What do you need? Which is going to be equal to the limit as h approaches 0 of, now, what we're going to have to do is we have to plug this x plus h into this function. So we have this, x plus h cubed, 2, so it's 2 times x plus h cubed. Let's just do this. Let's just do this. So what I'm going to have to do is I have to plug, x plus h into this cubic. So this is going to be equal to the limit as h approaches 0 of, well, everywhere there's an x, now there's going to be an x plus h. So 2 times x plus h cubed minus 3 times x plus h. And then I have to subtract off f of x. Now, we have to be careful because I'm subtracting off this binomial. So do not forget to put parentheses here. So this is going to be, 2x cubed minus 3x squared. Don't forget to subtract both of these things all over h. Now we're going to have to, simplify this x plus h cubed. Oh, and this needs to be a squared. We're also going to have to simplify this x plus h squared. And maybe we'll do some work over here. So x plus h cubed is going to be equal to x plus h times x plus h times x plus h. So we know when I FOIL this binomial, it's x squared plus 2xh plus h squared. And I still have this x plus h. So all these terms times x. So I'm just going to, multiply them all by x. So x cubed minus 2x squared h plus xh squared. And then these three terms times h as well. So put an extra factor of h in each one of these. X squared h plus 2xh squared plus h cubed. Now we can combine some like terms. I have x cubed, negative 2, actually that should be a positive. I don't know why that says negative, but I have a 2x squared h plus x squared h is going to be 3x squared h. And then similarly, I have an xh squared and a 2xh squared, so we're going to have 3xh squared and then plus h cubed. I don't have to do this x plus h squared because it's this trinomial right here. So this is now going to be equal to the limit as h approaches 0 of 2 times that. So x cubed plus 3x squared h plus 3xh squared plus h cubed. Minus 3 times that binomial, that would be this piece here if I wanted to do that, this x plus h squared. So x squared plus 2xh plus h squared. And I still have minus this 2x cubed, and then minus this minus is going to be plus 3x squared. And this is still all over h. So we're getting close. We're getting real close. All right, now distributing the 2. So this is going to be the limit as h approaches 0 of 2x cubed plus 6x squared h plus 6xh squared plus 2h cubed. So just 2 to all these. And similar, we're going to do a 3 to these 3 terms. So this is minus 3x squared. Minus 3 times 2 is going to be minus 6xh. And then minus 3 times h squared is minus 3h squared. And we still have this minus 2x cubed plus 3x squared. So one thing I can tell you is I know it feels like I'm moving fast, and I am for this video's sake. But when you're doing your homework, take your time. All right, now let's see what cancels. So, okay, let's just kind of look at the terms that don't have h in it, because those likely are going to go away. So this 3x squared, this negative 3x squared. I have a negative 2x cubed. I have a positive 2x cubed. Those are gone. And sometimes things that have h's in them will also cancel, or at least simplify a little bit. So this is going to be equal to the limit as h approaches 0 of, let's see, let's write that first. So we have 2h cubed, and then I have a minus 3h squared. I have a 6x squared h, and I don't see anything else like that. 6x squared h, and then I have a 6xh squared, and I have this minus 6xh. And let's make sure. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, we're good. And all over h. Notice that each one of these things have an h in them, so I can factor out that h, so that I can cancel one of these h's on the bottom. So factor out an h, this is going to be, 2h squared minus 3h plus 6x squared plus 6xh minus 6x, and then this is all going to be over h. So we can see that those h's will cancel, and now this function is defined at h equals 0. So we can plug in h equals 0. So f prime of x is going to be equal to, plug in h equals 0, 2 times 0 squared minus 3 times 0 plus 6x squared plus 6x times 0 minus 6x, and those zeros are going to go away, so this is going to be 6x squared minus 6x. Now, the benefit of finding the derivative of function, the general derivative, is if I was asking to find the tangent line of a function at, multiple different tangent lines, I should say, at multiple different x naughts, instead of having to evaluate the tangent at each one of those, or the limit at each one of those x naughts, I can find the general definition, the general derivative, and then I can plug in that particular x value. Also, benefits of this is if you want to know where the function might have a horizontal tangent line, if I know the general derivative of the function, I can actually figure out when this slope is going to be equal to 0. So let's write that up in a quick example right over here, just because I have, that information. So you might see an example that looks like this. Example. Determine the slope of the tangent line at, x equals 2 and x equals, I don't know, say 5. So for this particular function, if I want to do that, I just have to find f prime of 2. And again, that's this function evaluated at 2. So 6 times 2 squared minus 6 times 2 So this is going to be equal to 6 times 4, or 24, minus 12. So the slope of the tangent line at 2 is going to be equal to 12. And again, since I have the derivative, I could just do exactly the same thing for 5. So this is 6 times 5 squared minus 6 times 5. So 6 times 25 is going to be 150 minus 30, which is going to be equal to 80. So the slope of the tangent line would be equal to 80 when x is equal to 5. Now, another example I could say is, when does the function have a horizontal tangent line? Well, this will happen when, the slope is equal to 0 or when the derivative is equal to 0. So let's just use the information I have here. So what I would do is I'd set f prime of x equal to 0, and then I can solve this. I can factor out a 6x, and I'd be left with an x minus 1 is equal to 0. So this would happen when 6x is equal to 0 or when x is equal to 0, and also when x is equal to 1. So there's a lot of benefits we can get if we know the general derivative of the function. I can answer these things really quickly, and then I can also figure out when I have a horizontal tangent line, which will eventually lead us to maxes and mins. All right, let's do say two more challenging ones, and that'll be it. So let's determine the derivative of f of x, which is equal to 2x over x minus 5, and we'll do this by the limit of the difference quotient. So f prime of x is going to be equal to the limit as h approaches 0 of f of x plus h minus f of x, and this will all be over h. So what I have to do is I have to evaluate this function at x plus h. So this is going to be the limit as h goes to 0, 2 times x plus h all over x plus h minus 5. That is the function evaluated at x plus h. And I still have to subtract off the original function, which is going to be 2x all over x minus 5. And this entire thing is going to be over h. So in order to simplify this expression here, what I need to do is I have to combine these numerators. So when you see rationals, you're going to have common denominators to be able to simplify this. So we're going to have 2x plus 2h all over x plus h minus 5. And then I'm also going to have to subtract this to 2x all over x minus 5. And of course, this is all over h. But our real goal here is to simplify the numerator before I worry about that h. So in order to do that, I need common denominators, and this trinomial is relatively prime to this binomial. So what I mean by that is if I was going to ask you, what is 2/3 minus 4 over 5? Well, 3 and 5 are relatively prime. They share no common factors. So what I'm going to do is I'm going to multiply top and bottom of this one by 5 over 5 and top and bottom of this one by 3 over 3. So very similarly, top and bottom of this first fraction by the denominator of the second, and top and bottom of the second fraction by the denominator of the first. Now, what's going to happen is we're going to get a common denominator, so I really just have to add their numerators, and that common denominator is going to be the product of those two things. So this is going to be the limit as h approaches 0 of, well, that denominator is going to be equal to x plus h minus 5 times x minus 5. And we still have this, all divided by h. But I'm going to have, this numerator minus this numerator. So we could FOIL this numerator. This is going to be, 2x times x is going to be 2x squared. Outside is negative 10x. Inside is plus 2xh. And then last is going to be minus 10h. Now we have to be careful for this. We're going to have to subtract off, and that same kind of idea, like be careful. They're always going to have parentheses here when you're doing this subtraction. So when I multiply this monomial times this trinomial, we're going to have 2x times x, which is going to give us a 2x squared. Then I'm going to have a 2xh. And then we're going to have a 2 times minus 5, which is minus 10x. Now, to save board space and maybe a little bit of time, when I distribute this negative through this trinomial, what's going to happen is the first term will become negative. Really, all these signs are going to change signs. So this will now be negative and this will now be positive. So just be careful. Don't forget to subtract this entire thing. Okay. So now we can combine like terms in the numerator to simplify this thing. And let's see what we have. Well, I have a 10x and I have a negative 10x. Oh, not that one. A negative 10x, which is this one. And anything else? Yes, right here. I have a negative 2x squared and a positive 2x squared. And I think we are good. Okay, so let's oh, I actually have another one. My bad. So I have a minus 2xh and a positive 2xh, so that is gone. How convenient. So what we're going to have now is going to be this negative 10h over this, this product of these two trinomial and binomial respectively, and then this is still all going to be over h. So let's talk about this over h part. Very similar to what we did before is this over h, this, divided by, I was hoping that'd be a different color. Let's do this in orange then. This divided by this h is the same thing as divided by this h over 1. So what I'm trying to say is divided by h over 1 is the same thing as multiplying by 1 over h. So that's going to take care of this division in this h over 1. And then I'm still going to have the limit as h approaches 0 of, this numerator over this denominator. So we have this negative 10h minus 10h. And then the bottom, we're going to have this x plus h minus 5 times x minus 5. Now we can see that these h's will cancel. And this function now can be evaluated at h is equal to 0. So this is going to be minus 10 all over x plus 0 minus 5 times x minus 5. So this is going to be equal to negative 10 all over x minus 5 squared. So cleaning that up, f prime of x is equal to this negative 10 all over x minus 5 squared. All right, one more. So our last example is going to be find the derivative of f of x, which is equal to 7 over the square root of 4 minus x. Now what we're going to see here is since this is a ratio, we're likely going to have to do common denominators. And also since this is, has a radical there, we're likely going to have to do conjugates as well. So let's see this in practice. So this is going to be the limit as h approaches 0. Now remember, I have to do f of x plus h. So the first function is, plug in x plus h here. So this is the square root of 4 minus, now be careful, x plus h needs to go in parentheses. And then minus the function 7 over the square root of 4 minus x. And this is all going to be over h. So, simplifying this is going to be equal to the limit as h approaches 0. We're not really simplifying much, but my goal is let's rewrite this denominator as the square root of 4 minus x minus h. And what I'm going to have to do is I'm going to have to subtract these two ratios up top, so I'm still going to have minus 7 over the square root of 4 minus x. And this is still all over h. Now, in order to subtract these things, they have to have common denominators, and since these denominators are relatively prime, I'm going to have to do the first fraction times top and bottom of the second denominator, and then the second one by top and bottom of the first one's denominator. Okay, so let's see what we get here. I am going to get the limit as h approaches 0. Now, this numerator is going to be 7 times the square root of 4 minus x minus this one, which is minus 7 times the square root of 4 minus x minus h, all over that common denominator, which is going to be the product of these two radicals. So we have a 4 minus x, and then a 4 minus x minus h. When you start getting used to this, complex fractions, we know that this h is on the bottom, which is going to be the same thing as multiplying by 1 over h. So a lot of times we will handle that and just kind of put our h here, but let's take our time. All over h. Okay. So what I need to do is I'm trying to simplify this thing. I'm trying to really get rid of this h, which is of course going to go in this denominator in a minute here. But in order to do that, I need to finish simplifying this numerator. And what I can see is I have, a radical minus another radical. And that's kind of the hint to say, well, if I want to simplify this or I want to factor this radical, I'm going to have to use its conjugate. So we're going to do 7 times 4 minus x plus 7 times the square root of 4 minus x minus h. That's the conjugate to the numerator, so I'm going to still have to do that to the denominator as well. Okay, so what's that going to do for us? Well, when I FOIL the numerators, we can tell that what's going to be nice is this is going to be the limit as h approaches 0. When we FOIL the numerators, 7 times 7 is going to be equal to 49. And then root 4 minus x times root 4 minus x is just going to be 4 minus x. But remember, it's 49 times, that quantity. Now, outside is going to give us 49. So plus 49 root 4 minus x, also root 4 minus x minus h. And inside is actually going to give us the same thing except negative. 4 minus x root 4 minus x minus h. And then last, we had this negative 7 times a positive 7, so minus 49 times, well, the product of these two radicals. So the radical is going to go away. We're going to have 4 minus x minus h. And then this is all over, this denominator, which we have our 4 minus x. And then this is going to be the square root of 4 minus x minus h. And I still have multiplied by this binomial, so 7 times the square root of 4 minus x, and then plus 7 times the square root of 4 minus x minus h. We don't want to distribute the denominators here because they're not conjugate, so we just write them in factored form. Now, remember this, dividing by h is the same thing as multiplying by 1 over h, so what I'm going to do is I'm just going to put that h on the bottom there, multiplying by 1 over h. And then we're going to clean things up. So, first things first, the 49 with those two radicals, negative 49 with those two radicals will cancel. And now I can distribute this numerator, so this is going to be the limit as h approaches 0. 49 times 4, less than 7, should be 4 less than 200, but so 196. So 49 times 4 is going to be equal to 196 minus 49x. And then over here, I'm going to have a minus 196, and then 49 times negative x is going to be plus 49x, and then negative 49 times negative h is going to be plus 49h. And then this is all going to be over, that monstrosity of a denominator, but h times the square root of 4 minus x, square root of 4 minus x minus h, and then times the binomial 7 root 4 minus x plus 7 times the square root of 4 minus x minus h. Okay. Woo. All right. So without writing so much, I'm going to do some simplifying. We're going to do some canceling after that with that h. So doesn't have an h. Those 196 go away, which is awesome. Same thing with the 49x's. So now this thing is going to simplify to this 49h over h. I usually like to rewrite it because I don't want to. You have to do, the additions and subtractions before we can finally, cancel that h. But I am feeling like I'm going to be out of room here. So let's do this in orange. So now these h's will cancel. Be careful. Isolate the h so that you can factor it out first. So, and then now I know that this function is defined at h is equal to 0. So I can now plug in h is equal to 0. So the top, there's still this 49. The bottom, we're going to have root 4 minus x. This is going to be the square root of 4 minus x minus 0 times 7 times the square root of 4 minus x plus 7 times the square root of 4 minus x minus 0. All right, what I can do is I can now simplify that. This 4 minus x minus 0 is nothing more than 4 minus x. Same thing over here. This 4 minus x minus 0 is nothing more than the square root of 4 minus x. So uh, root 4 minus x times root 4 minus x is just going to be 4 minus x. So f prime of x is going to be equal to 49. This is going to be 4 minus x. And I can also factor a 7 out of that binomial, 7. And what we're going to have is we're going to have let's do it this way. Actually, instead of doing that, it's going to be 14 of those. We're going to have 14 of those root 4 minus x's. So I have 7 of something and then another 7 of the same thing, which means I'm going to have 14 of those particular things. So 14 has a factor of 7 in it, so I can factor a 7 on the top, so this would be 7, and then I'm going to have 2 times 4 minus x times the square root of 4 minus x. And to finish this out, 4 minus x is to the power of 1. Root 4 minus x is the power of 1 half. So I can add that power of 1 to the power of 1 half and get power of 3 halves. So this will be 7, 2 times 4 minus x to the 3 halves. If you like the content, please subscribe.